We are live to tape, so good morning once again, everyone. Welcome to this Monday's plenary lecture. And we're going to cover a very interesting topic today, an argument proposed in the 11th century by St. Anselm, a Christian monk, who came up with a logical proof for God's existence. This is, I think, and many philosophers agree over the centuries, this is the most clever proof that's ever been devised, but that there still must be something wrong with it, since it seems prima facie impossible to prove such a thing by means of logic alone, since logic, as some of you probably know, pertains only to the validity of internal arguments based on their own structure. And does not pertain much to the real world. So it's really extraordinary that St. Anselm firstly came up with this proof, and secondly that there's been ongoing discussion of it for 1,000 years, and some of the most important philosophers in the West, some of whom we've already glimpsed, such as Hume and Kant and Descartes, they all tried to pick apart this argument, even though certainly Descartes and Kant were believers in God, and Hume wasn't. That's not the issue. The issue is not whether you have faith in the existence of God or not. The issue is to ascertain by rational means what might be logically wrong with this proof. You understand? So it's, if you could find something wrong with the proof, that's not going to shake your faith in God necessarily. Or indeed, if you fail to find something wrong with the proof, that's not going to cause you to believe in God necessarily. So it's an exercise in philosophy. We're trying to ascertain what, if anything, is going wrong in this argument. And that is really the job of our class today, to look at the argument, and then actually on Thursday in my breakout group, I'm going to go over some of the rebuttals to the argument historically that are most important. There's a link to a very good page. In your Google Drive folders, you'll see a link to a page that summarizes some of these main rebuttals over the centuries, and you may agree or disagree again with some of them. I personally think that Kant and Hume did probably the most rigorous job in refuting Anselm, but they're a little bit difficult. Hume's refutation is probably more difficult to grasp than Kant's, although Kant's is probably decisive. And we'll go over that on Thursday in my breakout group, section M, and I'm assuming that you will go over this as well in your independent breakout groups. But before we do that, obviously, we need to get a handle on the argument itself. So what is Anselm demonstrating, and how is he demonstrating it? That's the first step. Once we understand Anselm's argument, or proof, he calls it the ontological argument, but in philosophy, remember, an argument is actually kind of a proof. The conclusion of an argument would be the thing you're trying to prove. So once we get a handle on that, and it may immediately dawn on some of you, I know from experience that once you get his argument, there's like a light coming on in your head. Some of you may not see that light immediately. You may have to read it a couple of times or think about it a couple of times, and then suddenly that light will come on, and you'll see, what a clever argument this was, whether it's valid or not. It's very clever. So that's our challenge this morning. And in order to do that, I need to do some preliminary work with you on understanding the nature of proof itself. This is a word which, like many words in contemporary society, is very much abused. And by abused, I mean it's used to mean all kinds of things that it doesn't really mean, strictly speaking. Although meanings, of course, you could say, as Wittgenstein says, that meaning is really driven by usage, that if everybody says blue and they mean green, then eventually, the word for green is going to be blue just because everyone's using it. I grant you this. That there's a certain arbitrariness to language, but there's also a certain precision to language. And if we're going to try to speak rigorously, write rigorously, and think rigorously, then we really want to retain some precision of meaning. So it's not the case that anything can mean anything. That kind of semantic relativism will only lead us into chaos. This is what I want to say to you, that if we're doing logic or we're doing mathematics, then proof has very specific meaning. And that's the meaning I want to focus on this morning. So, for example, some of you may have been taught or may have just picked up from the airwaves that science proves things. Scientifically we can prove this or that or that. That's not true. And no scientist across the street would tell you that they've proven anything. Science describes things. Science explains things that we didn't understand before. Science, a lot of times, predicts things, or indeed retrodicts things. Science certainly hypothesizes things, and then by experiment, we either confirm or disconfirm the hypotheses. But that falls short of mathematical and logical proof, yeah? Do you understand? There's a gap between a confirmation of an hypothesis and a proof of something. Because a proof of something is really deemed to be, in a Platonic way, residing in a space that's purely logical and that's going to be true everywhere and for all time. So if you prove that 1 + 1 is 2, then you know that's going to be true on the moon. It's going to be true when we get to Mars. It's going to be true in other galaxies. It was probably true from the beginning of time, and it will be true till the end of time. But if we demonstrate that there are no other planets in this solar system with life on them, that's not a proof, right? That's just a demonstration. If we then discover life that we didn't hitherto notice, then we will have simply refuted our own observation. And that's what science does. It makes observations, it makes predictions, it gives us really good explanations for a lot of things, but they're all subject to change, and they're subject to restriction to their particular domain. So Newton's laws are not proven to be true by any stretch of the imagination. Newton's laws are excellent and accurate approximations of motion in Newtonian domains. That's how we got to the moon and back. If Newton's laws were not correct in the human domain of planetary space travel, we wouldn't be able to launch satellites into orbit. We wouldn't have gotten to the moon or back. But that is not a proof that Newton's laws are true, because they're not true everywhere. When we get to the quantum world, Newtonian mechanics breaks down and quantum mechanics asserts itself. When we get to very large velocities, then relativistic mechanics take over, and Newtonian mechanics are not the most accurate ones. You see? So science is not proving things about the world. It's explaining, it's observing, it's hypothesizing, it's confirming, it's disconfirming. And none of that is proof. Okay, is that much clear to you? It's important, yeah, to understand what really a proof means or doesn't mean. Any questions or comments about this before we go on? Everybody happy with this so far? I haven't subverted too many of your beliefs yet this morning. Okay, I'll try harder. All right, so now let's look at, there are basically 3 kinds of proofs that I want to describe to you. And they are called direct proofs. And I'm going to show you a slide. That's in your folder also. Direct proof is the most satisfactory way of getting from what you want to prove to an actual demonstration of it, because in a direct proof we have this advantage of being able to go step by step by accepted rules of inference, and we go from the premises of the argument to the argument to the conclusion, and everybody can see how each step is justified, and so everyone who follows the proof is satisfied that the conclusion is valid. Okay, that's the main strength of direct proof. We have in logic something called truth-preserving rules. These are rules of inference that allow us to go from one step in an argument to the next step in an argument. The same is true in mathematics. So Euclidean geometry is the paradigm for this, where Euclid's proofs are direct proofs, and they're very clearly laid out, and he's always able to demonstrate what he wants to demonstrate, and you can see every step. You could see every argument. If you want to look at the proof of the Pythagorean theorem or a simpler theorem, you could see it's very beautifully laid out, and we can all understand how he got there, and we all believe the result because we could follow step by step directly. Okay, that's a very satisfying kind of proof. It turns out, however, by some quirk in the universe, that not everything can be proved directly, and sometimes we have to resort to a kind of a trick, which is called indirect proof. And indirect proof rather than directly proving the thing that you want to prove, because sometimes people can't find a direct proof, and there's some very important theorems which simply have not admitted of any direct proof, so people have to find a more circuitous route, and indirect proof offers that to us. An indirect proof, and I'm going to give you examples of these things in a moment, I'm just clarifying the terminology for you. An indirect proof is different structurally. It begins by assuming the contrary of the thing that you're trying to prove. And so you start by assuming the logical inverse of the thing you try to prove and then derive a contradiction. And if you can derive a contradiction, it means your assumption was false. And if your assumption was false, it means the negation of your assumption must be true. So in other words, if you're trying to prove X, whatever X stands for, and you can't do it directly, you can always adopt the following indirect strategy. You can assume not X, right? The logical negation of X is not X. So if you want to prove X, you could assume not X. If you can derive a contradiction from that assumption, then you know that not X must be true. Because if you derive a contradiction under not X, then not X must be false. Anything you derive a contradiction under must be false. So if not X is false, then the negation of not X, namely not X, must be true. And if not X is true, then X must be true, because the negation of a negation is logically equivalent to an affirmation in natural languages as well as in arithmetic and in logic. So you're able indirectly to prove X by assuming not X, deriving a contradiction, showing therefore that not X must be false, therefore not X must be true, therefore X itself must be true. That's indirect, obviously indirect. And it works fine in mathematics and in logic for the most part, although there are some purists who don't like it because there's just something a little bit fishy about indirect methods like this. Not so much in logic, it really does stand up well, but Anselm is going to use half of his proof, or the really interesting part of his proof is indirect. So that's why it's really important for us to get a handle on how indirect proof works. So when you encounter it in a few minutes with Anselm, you'll see the strategy in place and you'll understand what he's doing. Okay, that's part of the background. That's why you can't just read Anselm if you haven't had logic. All right, that's part of it. And I'm saying in logic it's still okay for the most part. Logicians use it. If those of you who are really interested in this, there is one branch of mathematics called intuitionism, and it was founded by a Dutch mathematician earlier in the last century named Leo Brouwer, and he and his school of mathematicians were not happy with indirect proof, and they tried to rewrite the whole canon of mathematics using only direct proofs. They would not accept indirect proofs. It turned out that not everything that mathematics uses on a daily basis, mathematicians employ a whole host of proofs, and it turns out that a lot of these things that they employ regularly cannot be proved directly. So most mathematicians accept indirect proof. The intuitionists didn't, but then their textbook of proofs is much smaller because there's a lot of stuff they couldn't prove directly. They just had to leave it out. In natural language, let me give you a flavor of the difference. I think it's in natural language. In semantics, we really see a big difference between an affirmation and a double negation. For example, suppose I say to you that Jane is a hard worker. Okay, let's say Jane is a hard worker. That's an affirmation about Jane, right? It's an is statement, right, about Jane. It tells us that Jane is a hard worker, right? Okay. Now suppose I say to you that the following. No one would say that Jane isn't a hard worker. No one would say Jane isn't a hard worker. Now logically, that has the same force as Jane is a hard worker, right? Because if no one would say Jane isn't a hard worker, then the implication is that everyone would say that Jane is a hard worker. That's the logical implication. But do you feel that there's a different meaning? Do you feel semantically that to say on the one hand Jane's a hard worker is an affirmative statement, right? But to say on the other hand, well, no one would say that Jane isn't a hard worker, doesn't that sound different to you in terms of what it means? Yes or no? You feel that there's a different kind of insinuation going on there, right? And that's the effect in natural language of a double negation. Yes, it sounds a bit doubtful. That's right, Denise. It's not the same as a direct affirmation. But this is only semantically. Logically, it means the same thing. And when we use that kind of a double negation in English or any natural language, or indeed when we use it in arithmetic, we get back an affirmation, right? The negation of a negation is an affirmation, right? Minus minus 5 is equivalent arithmetically to plus 5. I mean, there's no argument about that. So a double negation is an affirmation, yeah? All right. And that's how it goes, all right? If you want a philosophy joke now, if you're ready for a very famous philosophy joke, I can tell you one. Maybe now it's late enough in the term you're going to get these jokes. There was a very, very famous, witty, extremely witty professor of philosophy at Columbia named Sidney Morgenbesser. I met him. I don't know if he's still alive, but in any case, everyone was afraid to give talks when Morgenbesser was in the audience because he heckled people remorselessly, but his wit was rapier sharp. So every philosopher who saw him in the audience was worried because he would heckle you, and he was always right on point. And one day, a very distinguished British philosopher came to give a lecture. A.J. Ayer came to give a lecture on the philosophy of language, and he didn't know about Morgenbesser. Morgenbesser was sitting in the back row, and he didn't know about this. He was an Oxford philosopher, a very upright gentleman, and he came to give this lecture on philosophy of language, and he said, and I'm paraphrasing what A.J. Ayer said to the audience, he said, "Isn't it curious that in natural language, and indeed as in arithmetic, a double negation is always equivalent to an affirmation, right? A double negation is equivalent to an affirmation." He said, whereas a double affirmation is not equivalent to a negation. And Morgenbesser from the back row said, yeah. So some of you are smiling. Okay, so that is like the ultimate put down. And if I tell this to non-philosophers, they just sit there. Try this at home. Nobody will get this. But it's really amazingly brilliant, okay, and very funny. If you're a philosopher, you'll be rolling in the aisles, you know. If I tell this joke to philosophers who haven't heard it, they're immediately, hysterically laughing. But you get the point, okay, about double negations and double affirmations. All right. Now, the third kind of proof, enough humor. Now, the third kind of proof is called inductive, and we're not going to deal with that this morning. Some of you must have heard of induction, mathematical induction or logical induction. Have any of you have heard of that? That's where you don't prove things. If you have a long list of things you need to adopt in your proof, you kind of jump, you assume that it's true for k, and then you prove it's true for k plus 1, and then that's considered to be a proof. That's called mathematical induction. And that seems to work as well as a form of proof. And those are the three main ones. Okay, so just to recap, we have direct proofs. I'll give you some examples momentarily. We have indirect proofs. Anselm's argument is going to employ that. And then we have inductive proofs. I'm not going to touch on those this morning because we don't need to bother with them. But again, making inductive statements can be very dangerous empirically because assuming things to be universally true empirically is not the same as assuming them to be universally true logically. We've come up with that before. So be careful of making inductive statements about the real world because they're bound to fail. You only need one failure in order to disprove the whole induction. So be careful when you make claims like all birds fly. If every bird you've ever seen flies, you might want to, and you're only in Central Park, you might want to make the inductive statement, therefore all birds fly. That would be wrong, because once you get to see an ostrich, you realize there are flightless birds. So when we make these inductive statements, which are big universal generalizations, they work in logic if they're made correctly using the technique of induction, but they don't work empirically. Be very careful. Okay, Thomas Hobbes said it, the great empiricist. He said early on in the Leviathan, we only looked at a chunk of it, right? But he said early on that just because, I'm paraphrasing him, he said just because the sun rises every day and sets every evening doesn't mean it's going to do so until the end of time. And we know he's right now because we know via contemporary astronomy. I hate to break it to you in case you didn't know, but one day the sun is going to turn into a supernova, and then it will, after that, become, some kind of a neutron star and a black hole, and that will be the end of sunrise and sunset. All right? So basically, it's true that if you make general statements about the universe, you're probably going to go wrong at some point. That's why induction doesn't work empirically. Okay, just a little aside. So the three main proofs, then, I'm going to type in the names of these things. There's direct proof, indirect proof, and finally inductive proof. And we're not going to touch on induction. You can look it up. It's not a state secret. Just let me type these in. Direct proof, indirect proof, and inductive proof. Now, a lot of you have probably proved things before. You may have used proofs. You may not have realized which kind of proof you were using, and that's fine. But we're going to obviously identify them by example this morning, at least direct and indirect. Okay, so here's a slide to illustrate some direct proof. Pretty straightforward, I think, and you can stop me if you have a problem with it. I hope you won't. But let me share the screen with you if I'm able, and then we'll just bear with me. Okay. Before we get to Anselm, I have it now on the screen. Although my slides for some reason seem backwards this morning. I'm not sure how that happened. It looks like the pages somehow became reversed. But in any case, no harm done. I'm going to share this with you, whatever kind of condition it's in. We're going to have a look at it. And we'll see what we can do. We can make sense of this. All right, let me see. Okay, that's at the end. This is at the beginning. Okay, it seems to be right now. So as I said, you can all see this, right? There are three kinds of proofs. Direct, which is the most convincing. Indirect. It works well in mathematics and logic, but it is a little bit suspect in natural language. As we saw, the inductive proof, handled with care, works well in mathematics and logic, but don't make inductive empirical statements because one disconfirmation will invalidate the entire universal claim. So we have to be careful when we speak inductively about the world. And these are the strengths and weaknesses of each, and these are the, this is the text summary of what I've just told you, that direct proofs work best because we can justify each step. Indirect proofs, well, if there's just something a little peculiar, because we want to prove P, so we assume the negation of P, then we derive a contradiction or deduce a contradiction. If we can deduce a contradiction by assuming not P, then we know not P is false. But if not P is false, then not P must be true. And the double negation is equivalent to the affirmation. That means P is true. That's what we wanted to prove in the first place. So we got there by indirect means. And that works fine in logic. And that's what Anselm's going to do, just so you'll realize the structure of it when you see it. And inductive claims, as I say, are subject to confirmation or disconfirmation, not proof. We don't really prove things about the world. We either confirm what we've hypothesized or we eventually disconfirm it. All right, here's a trivial example of a direct proof, but it illustrates what direct proofs do for us. If we want to prove, a theorem is the thing that we want to prove, and in this case we want to prove that when two straight lines intersect, the opposite angles are equal. I'm sure some of you knew this already. Do any of you know this from geometry? Yeah, it's a fairly simple theorem, right? In other words, we want to prove that angle A equals angle C, angle D equals angle B, and that's true for any straight lines. We don't care what the numerical values are, right? It's going to be true every time two straight lines intersect. So how do we do this directly? Pretty straightforward. First step, and I'm not giving you the justifications, I'm going to ask you for them. Every sentence in this proof is justified, okay, by a prior result or a rule of inference. So A plus B equals 180 degrees. Angle A plus angle B equals 180 degrees. Why? Can anybody tell me what the justification is? There is a justification. Anybody know it? Why do we assert why can we assert reliably that A plus B, angle A plus angle B, is going to sum to 180 degrees? Anybody know this? Maybe some of you know and don't know that you know. Well, A and B are subtended by a straight line, right? A plus B is in fact the angle that is measured on the line itself. Yes, a straight line. And a straight line always has 180 degrees on either side of it, yeah? Now that's a result from Euclid. Every straight line, it makes an angle of 180 degrees. A circle is 360 degrees, right? Every diameter cuts the circle in half and cuts the angular measure in half, right? A hemisphere is 180 degrees angle, yeah? Okay, so anyway, A plus B is 180 degrees, and B plus C is also 180 degrees. Why? Same reason, because that's a different straight line. So it's also 180 degrees. So notice, therefore, A plus B equals B plus C. How do we justify that step? Well, there's an axiom in Euclid. It says things which are equal to the same thing are equal to each other. So if two things are equal to 180 degrees, they must be equal to each other. Right? That's not complicated. It's an axiom in Euclid, things which are equal to the same thing. So that would be the justification for claiming that A plus B equals B plus C, because they're both equal to the same thing. So they must equal each other. Okay, therefore A equals C. How do we get to that step? That's what we wanted to prove. How does it turn out that if A plus B equals B plus C, therefore A must equal C? What's the justification for that? I'm sure most of you realize it's true. You're not going to argue with the conclusion, are you? But how did we get there? What did we do? Nobody knows? Well, we subtracted the same thing from both sides of the equation.
Yeah, if B is the thing that doesn't change and A plus B equals B plus C, then A has to equal C.
That's right. But A has to equal C because we can subtract an equal amount from both sides and not change the truth value of the equation, right? If an equation is true, then you can add or subtract whatever you want as long as you do it to both sides, right? Then you don't change the equality. If you add more to one side than to another, or if you take away more, to one side than the other, you multiply one side by more than the other, you're going to change the equality. It will become an inequality, but you're allowed to operate. These are arithmetic operators, and if you operate equally on both sides, then you don't change the actual logical value of the equation. It's still going to be true, right? So you subtract B from both sides. The short answer is you subtract B from both sides, and then you get what? That A equals C. You could also, that's the result we want, right? Because remember, what we were trying to prove was that A equals C. RTP means required to prove, right? Opposite angles are equal. So we've now done it in very few steps, yeah? And then you don't have to repeat yourself. You can then help yourself to this wonderful, I love this, because you can use it, save a lot. You say, similarly, it may be shown. You're going to go through the same argument again, but you're going to substitute the variables. Instead of A plus B, you're going to have B plus C equals C plus D, and then you're going to subtract C from both sides, and you're going to end up with B equals D. Right? But instead of repeating that process, you just say similarly it may be shown, because you're going to go through the same sequence of argument with different variables. So you can also show that B equals D, obviously. All right? And so that's it. Quadrate demonstratum. And then those of you who do mathematics or logic, you get to write QED. Maybe none of you have ever heard of that before. But that's what you want to write. You want to write QED, meaning I proved it. Okay, quadrate demonstratum. In other words, that's Latin, and there's a little Latin this morning in the mix. And whenever you prove what you were trying to prove, you get to brag about it and write QED. And that stands for quaderat demonstrandum, which in plain English means which was to be shown, right? We have to show this, we showed it, then you get to write QED. It's like an artist signing your work, When you finish a painting, you get to sign the painting, right? Well, when you prove something in mathematics or logic, you get to write QED. You get a big boost of self-esteem, better than Prozac, okay? Write QED, and you're done, all right? So that's a straightforward direct proof. And you see that direct proofs are very satisfying. Okay, what about indirect proof? Trickier, all right? Trickier. Because what we need to do is we assume the inverse of the negation of what we want to prove and derive a contradiction. That's the technique or the strategy of an indirect proof. And the reasoning is, as I've said, if you can derive a contradiction, then your assumption must be false. Whenever we arrive at a contradiction, it means our assumption must be false. It's like Zeno's paradoxes. He proved we can't leave the room, right? He proved Achilles could never, but there's something contradictory in there, yeah? That we know that his conclusions are contradictory. So there must be some false assumption in there, and that's what we are able to expose. Similarly, if you assume the negation of what you want to prove and derive a contradiction, then your assumption must be false, and that is the negation of what you want to prove is false, and so if the negation of a negation is false, the affirmation must be true, and therefore what you want to prove must be true. That's once again the strategy. Let's look at an example. That'll be the quickest way. I have a very brief example to show you. I have two. I wanted to show you this one because it's the simplest indirect proof that I know. And if you know a simpler one, feel free to tell me. But this is a proof that was known for some time, and it's a proof that there is no largest prime number. Can anybody say what is a prime number? What's a prime number? Anyone? A prime number? Prime. A prime number is a number that what? Is divisible by what? Only by?
Itself.
Yes, very good. It's divisible only by 1 and itself. Correct. Every integer is divisible by 1, but a prime number is divisible only by 1 and itself. Okay? Very good. So you know, at least some of you, what a prime is. Well, here's a proof that there's no largest prime. You might ask yourself, is there a largest prime number, right? Is there a prime number such that there's no larger prime? Because you find primes way out there. Computers these days, supercomputers, you could probably buy books online with just prime numbers in them. They used to make books of random numbers and books of prime numbers, and there's some very large prime numbers. People wondered, is there a largest one? Is there a prime number that's bigger than all other primes? No. And here's a proof, but it's an indirect proof, okay? An indirect proof that there's no largest prime. It's very simple. Okay? So we can't prove directly. No one has ever been able. It doesn't mean there's no direct proof. It just means no one has figured out a direct proof. But there is an indirect proof, which is quite clever. And it's as follows. We want to prove RTP, right? Required to prove that there is no largest prime. So we assume that there is one, and we derive a contradiction. That's our indirect strategy, right? So let's assume there is a largest prime, and let it be x. Okay, so x is the largest prime. All right, now we construct a new number y. All right, we construct the following number. And the number y is constructed as the product of all primes, right up to x. So 1 times 2 times 3 times 5 times 7 times, what's the next prime after 7? 11 times 13. We multiply all the primes together, including x, which is the largest prime of all. And to that product, we add 1. Okay, so we have this new number y. Now, I'm skipping a lot of steps, but you have to believe me, it can easily be shown that y is also a prime number. And by inspection, you yourselves can see that y is not going to be divisible by anything except itself and 1. First of all, it won't be divisible by 2 because it's an odd number, right? It's a product of a bunch of numbers, including 2, which means it itself is an even number, and then we add 1. So y becomes odd, so it's not divisible by 2. It's not divisible by 3, because it's a product of 3 times a certain number, right? What's in the brackets, plus 1, so 3 won't divide it. 4 won't, because if 2 won't divide it, 4 won't divide it, and so on up the line. And and by induction, right, which I mentioned this morning, you can prove that there is no number that divides y except 1 and itself, and therefore y is prime. But excuse me, y is larger than x, right? Obviously, by inspection, you could all see y is larger than x, but that's a contradiction. Because what did we assume? We assumed that x is the largest prime, and now we just, based on that assumption, constructed an even larger prime called y, and therefore x is not the largest prime, and that contradicts our assumption, and therefore our assumption must be false. And what was our assumption? That x is the largest prime. If the assumption that x is the largest prime is false, then there is no largest prime. Okay? QED. Is anybody happy with that? Is everybody happy with that? That's not difficult. But it's really very good. Yeah, it's a very good argument. No one can prove directly, not that I know of anyway, that there is no largest prime. It's very difficult to prove. But it's not difficult to demonstrate it by indirect means. Okay? Indirect proof. Anybody have any questions about that? Are we good? All right, that's an example of an indirect proof. The other slide has, I'll share one more with you. One more example of an indirect proof. It's a little more intricate, but it's still arithmetic. We're only using basic arithmetic and a little bit of algebra. There's nothing too daunting about this, really. Just some basic stuff. But the idea of it is to give you the flavor of how these indirect proofs work. Remember, that's the whole idea of this, right? So let me go back here. Here's another one. A simple proof. Again, we want to prove that if n squared is even, then n is even. N could be any number. It's an integer, right? Any integer. So if it turns out that if n squared is even, then n is even. You could think about this with some examples. Let's say n is 4, right? So 16 is even, and therefore, we know that 4 must be even. If the square of any number is even, that number must be even, okay? And this is true, but it's not a proof. Okay, we haven't proved it. We sort of know it to be true, but it's not a proof. Because we don't know. There may be some number out there that violates the inductive argument. So you can't just wave your hand and say it must be true. You got to prove it. Okay, how do we prove it? We assume that n squared is even, but n is odd. Right? And we're going to derive a contradiction from that. Okay? And the contradiction is very clever. It's very easy. Since n is odd, right? We've assumed that n is odd. So that means n is 2k plus 1 for some integer. That's the definition of an odd number, right? Twice the product of an integer plus 1 is always going to be an odd number. And so we square that, and we get a result algebraically. And part of that result, the inside the bracket, right? We have 2k squared plus 2k. We let that be m's for the sake of ease. We can then just observe that what we've done by squaring this number is we produced n squared is equal to 2m plus 1. And that means, by definition, n squared is odd. We've just produced a number from our assumption that is an odd number. But that's impossible, because we've already assumed n squared is even. So n squared can't be both even and odd. It's a contradiction. We've assumed n squared is even. We've proved it's odd. That's crazy, all right? So we know our assumption's false. But if our assumption is false, then it's not the case that if n squared is even, n is odd. That's impossible. So it must be the case that if n squared is even, n is even. That's the indirect proof again. Okay? So a little more intricate, not more complicated mathematically, just a little more algebra to parse. And you can go over that. That slide's in your folder if you want to satisfy yourselves that this is easy to derive a contradiction under, and therefore, if n squared is even, then n indeed must be even for all n, where n is an integer, and that's a proof by contradiction. All right, are we clear about this? Now, Anselm's ontological proof is going to be a proof by contradiction also. And that's why I took some time this morning to set this up for you. So you are happy, presumably, with what it means to prove something. And often in Latin we call such proofs reductio ad absurdum. An indirect proof is sometimes called a reductio for short. Reductio ad absurdum means reduction to absurdity. In other words, you derive an absurd or a contradictory result. You know your assumption was false. That's a synonymous way of expressing indirect proof. We call it a reductio. Okay. Now, there are two background assumptions to Anselm's ontological argument for the existence of God. And in order to appreciate his proof, we need to be able to see the validity of his assumptions, what he really wants to tell us about the nature of ontology needs to be accepted. If you quarrel with these things, then you just quarrel with his proof before he even makes the proof. But if these background assumptions are acceptable to you for the sake of argument, at least, right? For the sake of argument, then accepting these assumptions for the sake of argument will allow you to understand his proof. So let's look at the assumptions. Assumption 1, and he explains this, and the reading is in your text, yeah? You could read his original. Well, the original was in Latin. You have a very good English translation in your textbook. He assumes, firstly, that a thing that exists both in the imagination and in reality is greater than a thing that exists in the imagination alone. So in other words, things can exist in two ways for Anselm. Things can exist either in the imagination and in reality, in other words, in your mind and in the real world, or a thing could exist in your mind alone. Like a dream would be an example of a thing that exists only in your mind, right? Because you're the one who's having the dream. Presumably nobody else is having the dream, and presumably the dream is not happening in reality, right? So a dream would be an example of something that exists in your imagination alone, but not in reality, okay? Are there shared things that exist in our imaginations alone, but not in reality? Sure. As far as we know, unicorns exist in our imaginations, but no one's ever seen a unicorn in a zoo, I trust. No one's ever seen a herd of wild unicorns, right? Whether they're the ones with wings or the ones without wings. So a unicorn is something that exists in our imagination, but and all of us have the picture of it, but we don't really find any in reality. So that would be another example. And why is Anselm saying that a thing that exists both in the imagination and in reality is greater? Well, let me give an example that Anselm gives, or I'll give you a more up-to-date example. Suppose you imagine cooking a great meal and enjoying it, or having your friends and making this great meal for your friends and all enjoying it together. What would be greater, just imagining doing it or actually imagining it then doing it? Anselm says it'd be greater to imagine it and then do it. Right? Like, what's greater, the American dream that you just dream, or the American dream that you dream and then achieve? Anselm would say it's greater to dream it and then achieve it. You get the idea of what he's trying to illustrate? That something that exists, like imagine writing a great book, but then imagine writing the book and then actually writing the book. Anselm would say it's much greater to write the book than just to imagine writing the book. But of course it starts in your imagination. That's where these things begin. But for Anselm, it's greater if it has the existence in mind and also exists in reality. Are we clear about that as a sort of a notion of what is constitutive of greatness, so what it means for something to be great or to be greater than would mean that the thing that's greater than something exists both in the imagination and in reality itself. Are we clear about this? Yeah? You could imagine, the perfect relationship. Well, what would be greater? The perfect relationship that exists in your imagination alone, or the perfect relationship that exists both in your imagination and then actually exists in reality? Or the perfect holiday. Imagine taking a dream vacation. Anselm would say, well, if the dream vacation exists only in your imagination, it's not as great as the dream vacation that first you thought up and then you actually had the vacation. I think that's easy to argue. It would be greater to actually take that vacation than just to dream about it. You with me? Do you see the point? Is it reasonable? Okay, it's a measure of greatness. It's saying if things exist both in your mind and in the real world, then they're greater than things which exist only in the mind. That's his point, okay? And the second assumption that we need to make in order to get to his argument is the following. That if we speak about God, Anselm says, and I'm quoting his words in English, he says God is something of which none greater can be thought. And again, that really means semantically that it's the greatest conceivable thing. There's nothing greater than God, in other words. And most religions will say, if they're monotheistic, certainly they'll say that there's nothing greater than God, that God is the greatest of all things. So nothing greater than God can be thought. And that's the second assumption. Is that fair enough? All right. Because there's nothing greater than God. So God is therefore the greatest conceivable thing. All right? Or the greatest conceivable being to just to summarize it with initials. Okay? So that's where you go. It's an acronym. GCB is an acronym, and it means greatest conceivable being, or greatest thinkable thing, if you like. Okay. So those are the two background assumptions. So now, are you ready for the proof? We good to go? You're all fairly quiet so far, but now we're going to look at his proof. Any questions so far, or are we good to go? You're all happy this morning? Is it too early? Is that why? Okay, let's go to his proof. So here's the theorem, right? Anselm wants to prove that God truly exists. Yeah, that's what we need to prove. RTP, required to prove that God truly exists. In other words, that God exists both in the imagination and in reality, right? That's what he needs to prove. So how does he do this? Remember, the assumption in the background is that God is the greatest conceivable thing or greatest conceivable being. In our minds, we can think of nothing greater. That's the assumption we need, yeah? Okay. So here are two possibilities. 1 and 2 are basically two possibilities, either or. Anselm says it must be the case that either God exists in the imagination alone, or God exists both in the imagination and reality, right? I mean, this is the first, we call this a disjunction. It's an or statement, right? Either God exists in the imagination alone, in other words, God's a figment of our imagination, or indeed God exists both in the imagination and reality. Clear? I mean, those are the two possibilities. Either we've just dreamed up God and God doesn't really exist, or in fact God really does exist, yeah? In which case, God exists both in the imagination and reality. Now, if it's the case, if the second disjunct is true, if it's true, one of these two must be true. This statement 1 is an either-or statement. Either this is the case, or this is the case. One of these two must be the case. If this disjunct is the case, if God exists both in the imagination and in reality, well, then God truly exists, yeah? I mean, obviously. Okay, so the second one, the second point here is going to tell us that if God exists both in the imagination and reality, then God truly exists. That's one possibility. The rest of the argument, we now have to turn to the other possibility that God exists in the imagination alone, right? And derive a contradiction. That's how he's going to proceed. Because if God exists both in the imagination and in reality, then God truly exists. But suppose God exists in the imagination alone. How are we going to prove God truly exists? By deriving a contradiction. Okay? So here is the contradiction. The contradiction is here in steps 3, 4, and 5. So let's go step by step. Now we're supposing that God exists in the imagination alone, right? That's our hypothesis. That's our assumption. And if God exists in the imagination alone, and our definition of God is what? The greatest conceivable being, right? So if God exists in the imagination alone, then the greatest conceivable being exists in the imagination alone. I mean, that's just substituting our definition of God into that statement. So if the greatest conceivable being is God, and God exists in the imagination alone, then the greatest conceivable being exists in the imagination alone. Okay, fine, no problem yet. But in that case, here's where we get to the contradiction immediately. If the greatest conceivable being exists in the imagination alone, then Anselm says the greatest conceivable being is not the greatest conceivable being. Why? Because if the greatest conceivable being exists in the imagination alone, I can conceive of a greater being, namely, that being which exists both in the imagination and in reality. And therefore, it cannot be the case that the greatest conceivable being exists in the imagination alone. And if it's not the case that the greatest conceivable being exists in the imagination alone, then the greatest conceivable being must exist both in the imagination and in reality. And therefore, God truly exists. QED. Now, some of you may be sitting here in stunned silence. I assume the majority of you are, because it takes a little while to process this argument. But once you process this argument, a light is going to come on. I guarantee you, it's like that light bulb in a cartoon when you understand something and the light bulb lights up. Suddenly the light bulb will light up and you'll say, my goodness, this guy's just proved that God exists. Okay? Now you're smiling. Did the light come on? Did your light come on yet? Or are you just thinking about it still?
I think, but I still need to think about it.
Okay, you think you got it?
I think so.
Okay, you have to think about it. It's not easy. I mean, it is easy when you see it, but it's not easy at the beginning. Just remember, we'll go back over it again, that God is the greatest conceivable being, right? So there's nothing greater than God. And remember, the thing that exists, remember the other background assumption, right? The thing that exists in reality and in the imagination is greater than the thing which exists in the imagination alone. So the contradiction comes from assuming that God exists in the imagination alone, right? Assuming the first part of this disjunction, assuming that God exists in the imagination alone. But Anselm says if God exists in the imagination alone, then we're saying the greatest conceivable being, which is God, right? We're saying the greatest conceivable being exists in the imagination alone. But then the greatest conceivable being is not the greatest conceivable being. Because I could always think of something greater. If God exists in the imagination alone, I could think of something greater, namely God existing both in the imagination and in reality. That would be greater than the God which exists in the imagination alone. Since God is the greatest conceivable being, God must exist both in the imagination and in reality, because if God exists only in the imagination, God is not the greatest conceivable being. So to assume that God exists in the imagination alone is to set yourself up for this contradiction. That if God exists in the imagination alone, then God is not the greatest conceivable being, and that contradicts one of our fundamental assumptions. The only way for God to be the greatest conceivable being is for God to exist both in the imagination and in reality. And so God must truly exist. You think about it. And the same reasoning, and read Anselm. Maybe Anselm's clearer than me. I've just basically summarized this for you to try to make it clear. His argument is the same. It's in the text. It's more long-winded and more elaborated and more embellished because it's a translation of medieval Latin into English. It's not as easy to read. I've tried to put this into a more compressed structure for you. But here's another way of understanding it. Because Anselm, when you read him, if you haven't yet read him, and I think you should, Anselm goes on to say that if somebody's an atheist, then they're contradicting themselves for the same reason. What's an atheist? What is an atheist?
Does not believe in God.
Right? Or rather, an atheist believes that God does not exist. Right? To be logically more specific. Yeah, an atheist does not believe in God, but that also means that an atheist believes that God does not exist, right? An atheist is not saying there's a God out there, but I don't believe in it. An atheist is saying, I don't believe that God exists, yes? Right? But when Anselm says, look, if you meet an atheist, and the atheist says that that God does not exist, and maybe there are some atheists out there, and so I'm sure you'll agree that to be an atheist means to believe that God does not exist. Anselm says, wait a second, because the atheist understands the same thing that God means as a theist does. A believer says that God is the greatest conceivable being. An atheist understands that God also is the greatest conceivable being, and yet doesn't believe that the greatest conceivable being exists. And Anselm says, so the atheist is contradicting himself. Because when the atheist says God does not exist, the atheist is saying the greatest conceivable being does not exist. But then you could say, but wait a second, you're saying the greatest conceivable being doesn't exist, therefore you're not conceiving the greatest conceivable being. Because I can think of a greater one, namely the one that exists both in your imagination, that you're denying exists, and also exists in reality. That would be a greater conceivable being than the one whose existence you're denying. So if you, the atheist, say that God does not exist, you're contradicting yourself.
Couldn't you just not believe that there is a greatest conceivable being? Because what gives us the proof that there is some greater being than ourselves?
Right? So if you, that's a different kind of attack, Ruby. So if you're going to say, I don't believe in a greatest conceivable being, then you're not playing this game. Then you're taking yourself out of the picture. You're saying, listen, I'm not down with this cause, and I'm not going to assume anything about God, and therefore you will not really be caught up in Anselm's logic, right? If you're going to say, I don't see why we have to believe in a greatest conceivable being. But then Anselm didn't really deal with that, because most people who, and there were very few atheists in his day, if any, but the atheists he met would all be saying pretty much what other atheists are saying today, namely they don't believe in God. And so if you straightforwardly don't believe in God, then Anselm would say to you, if I'm playing Anselm's role, Anselm would say to you, well, so you don't believe in the greatest conceivable being? You mean there's some limit to our conception? Do you believe, therefore, that there are some things we can't conceive? You see, that's another kind of trap, right? Because if you're going to say, well, I don't believe in God because I don't believe in a greatest conceivable being, then you believe in some limit on what we're able to conceive. I mean, sounds like. And then Anselm would say, if you believe that there's a limit on what we can, where do you draw the line? Like, what's the greatest thing you can conceive beyond which you can't conceive anything?
Yeah, I'm in the, I guess, I don't know if you're asking, I'm in the not playing the game boat because I don't believe there's a limit in what we can conceive. I think I could conceive a greatest conceivable being.
Okay.
However,
if you could, so this is the thing, is I think that, and this is an interesting objection that you're raising, Ruby, and that's why I'm walking down this path with you, because it leads back to the notion that you really could conceive. It's like infinity. You know, can we conceive infinity? Well, yeah, we can't conceive a number. Infinity is not a number. There's no largest number, but we can conceive of something that never stops increasing, right? We can conceive that numbers go on forever. So we're conceiving of the greatest possible sequence of numbers, which is an infinite sequence. So if we can conceive of infinity, why can't we conceive of God? Because God is supposed to be knowing everything, right? Everywhere, omniscient, omnipotent, omnipresent. You know, God is all-powerful, all benevolent, all-seeing, all-knowing. That's infinite also. It embraces all. So yeah, we can conceive of that. The issue is not whether we can conceive of it. I think the issue for most people is whether they believe it or don't believe its existence. And then you have in the middle agnostics who don't believe or disbelieve it. Agnostic says, well, I'm waiting for proof. Like an agnostic says, I don't know whether I believe in God or not. If someone could prove God exists, I believe it. If someone could disprove God exists, I believe it. But right now I'm skeptical, so I'm on the fence. He's not addressing agnostics, he's addressing atheists. So he's saying if you're an atheist, you're denying that the greatest conceivable being exists in reality. So he's just going to play the same trick on you. He's going to say, well, if you're denying that the greatest conceivable being exists in reality, then it's not the greatest conceivable being. Because the greatest conceivable being must exist both in your imagination and in reality in order to be the greatest conceivable being. And therefore God truly exists. So he says the atheist is contradicting herself. according to the same logic. So even if you're resistant, and I think you are, and I think it's good to be skeptical and resistant about everything. That's what philosophy is. We're all skeptics, and sometimes that's a good thing. But here's the problem: if you are skeptical, you're still seeing there's some really important point being made here. And what's wrong with the argument? Either you're convinced by the argument or you're not. And if you're not convinced by the argument, as I said last day, and this morning, the art is to try to figure out what's wrong with the argument. That's what the debate's been for 1,000 years. Whether people believe in God or not is not the debate. The debate is that both philosophers who believe in God and philosophers who don't believe in God have been trying to figure out what's wrong with the argument. Because it doesn't seem rational that you could prove God's existence by logic. And yet he apparently has just done so. All right, are there any other questions about this? This is the structure, basically the structure of the argument. And I just want to know if anybody else out there, there are some of you out there, I just want to know how you're doing. Are you digesting this? Are you getting this? What if you don't believe in a singular God, says Randy. Okay. Wait a minute, now let me back up here. Matthias, I'll come to you in a moment. Doesn't this disprove the assumption that God... No, it doesn't. Matthias, I'll come back to that. That's a good question. And Randy's saying, what if you don't believe in a singular God? That's also an excellent question. I'm going to address both Randy and Matthias. First Randy. So, Randy, I thought about this myself over the years. In other words, we're talking about polytheistic religions contrasted with monotheistic religions, right? For example, if we're talking about the Abrahamic faiths, this is most straightforwardly applicable to Judaism, Christianity, and Islam because they are mostly talking about one God, right? So that kind of God is the one Anselm's referring to. So the argument is really constructed in such a way as perhaps to make the most sense directly to proponents of Abrahamic faiths, which are monotheistic. But if, as Randy says, what if you don't believe in a singular God? That would imply that you believe in many gods, not one, all right? And we have such religions. They're called polytheistic, right? Religions with more than one God. So, for example, Hinduism is an excellent case. There are multitudes of gods. The Greek pagans had a multitude of gods also, right? A pantheon of gods on Mount Olympus. And in Indian philosophy, you have multitudes of gods also, all kinds of deities. All right. So here's the question: Does Anselm's argument go through with Indian religions? And I think it does, Randy, and for the following reason. That when Indians have all these different gods and goddesses that they worship at different times, at different festivals, and so forth, there's still one sort of chief executive god, right? There's like a CEG. There's a chief executive god in charge of all the others, which is Brahman. Okay, that's the number one god. That god is on the top of the food chain. And Brahman is defined as ultimate reality. Ultimate reality. So Brahman is the god that encompasses all the other gods as well as everything else. So Anselm's argument would go through. You would just replace God in his language with ultimate reality, and you'd get the same argument. If you believe that ultimate reality exists only in your imagination and not in reality itself, then it's not ultimate reality. Because ultimate reality must exist both in your imagination and in reality, or it wouldn't be ultimate reality. So that argument would go through in Indian philosophy, or it would go through in Greek philosophy, where Zeus is, I guess, the chief executive god. So, you'd have to believe in Zeus as the greatest conceivable god, and so forth. All right, so I think, Randy, that's one answer, possible answer to your question. Now we'll come back to Matthias. Okay, back to Matthias. Doesn't this disprove the assumption that God is the greatest conceivable being? No, Matthias, it doesn't. It actually uses that assumption to prove that God must exist in reality, because it is the assumption that God is the greatest conceivable being for Anselm implies that something that exists both in reality and the imagination, is greater than something that exists in the imagination alone. So if God is the greatest conceivable being, God must exist both in reality and in the imagination, or the greatest conceivable being wouldn't be the greatest conceivable being. So you're not disproving that God is the greatest conceivable being, you're disproving the assumption that the greatest conceivable being could exist in the imagination alone. Because then it wouldn't be the greatest, because I could think of a greater one, namely the one that exists in the imagination and in reality. Okay? I hope that's clear. Think about it. And now Nama comes up with, I like it, Nama, because you're dragging Plato into the argument, which is very, very good, very smart, okay? To think about Plato. I'm glad you haven't lost sight of Plato yet. I hope you never do. So what would Plato say about this? Well, Plato, remember, was pre-Christianity, right? So Plato had all these gods out there. So Plato would say that ultimate reality is just ideas, yeah? So Plato would disagree, right? Because Plato would say that actually things exist in reality that don't exist in our imaginations. Plato would maybe stand this on its head. I'm not saying I know what Plato would say. I'm saying we could imagine, because remember, the pure forms are out there whether we know them or not, right? Our job as humans is to use the power of our minds to apprehend the pure forms, right? That's Plato's notion. And so those pure forms are there before we exist. Those pure forms existed before there were humans on the earth to come up with religions even, right? The pure forms are always there. So Plato would say, maybe, that actually, Anselm, you're wrong, because the greatest things out there exist only in reality, but not necessarily in the imagination at all. So the greatest conceivable thing for Plato is a pure form, which exists only in reality, but we have to imagine them because they're outside of space and time. So Plato would take this argument to a totally different place. Yes? Totally different place. But you can't use Plato to refute Anselm in a sense, because Plato came before Anselm. We can only guess what Plato would have said had Anselm shown in this argument. We don't know what Plato would have said, right? But we do know, without a doubt, what Descartes said and what Hume and what Kant said and what some other contemporary philosophers have said to twist. They've really twisted this into some strange shapes to bring out the strangeness of its logic. And we will look at those things on Thursday, and I hope you will in your breakout groups. There are some really, really good objections out there, including an objection by a Platonist. These guys were all Platonists too, by the way. But we'll see. One objection by Gaunilo, one of the monks that Anselm mentioned himself in his reading, is the monk Gaunilo. If you read Anselm, you'll see Gaunilo's objection is really neat. Gaunilo says, well, wait a second. Does that mean that if I can dream up the most perfect tropical island, imagine a perfect tropical island with beaches, beautiful beaches, and coral reefs, and coconut palms, and great weather. Just imagine a perfect tropical island, right? So Gaunilo says, well, wait a second. If I can dream up the perfect tropical island, then it must exist, according to your logic, Anselm. If I can imagine the perfect tropical island, then I ought to set sail looking for it, shouldn't I? Because if it's the perfect tropical island, then it must exist in reality, as well as my imagination. Otherwise, it wouldn't be the perfect tropical island, right? If it only existed in my imagination, it wouldn't be as perfect as the one that exists in imagination and reality. So if I can dream up the most perfect tropical island, then actually I ought to go looking for it. That's the objection that Gaunilo made to Anselm's argument. Anselm refuted him by saying, no. He said, because the idea of a tropical island and the perfection of a tropical island is a changeable perfection, because if there's a hurricane or a storm blows up, trees are going to come down, the sand's going to erode, maybe with tidal waves, or any number of things could happen to that island which would actually change its state of perfection. And so it wouldn't be perfect any longer. And that means that, the ideal perfect tropical island doesn't really exist in reality because it's subject to change. The only thing that could exist in reality, the only truly perfect thing that could exist in reality would not be subject to change. And that would be God, because God is not changeable. So he refutes Anselm that way. I mean, he refutes Gonilo that way, by saying, like, islands are material things and they will be subject to change, and therefore become less perfect in time. But God is not subject to change, and therefore God does not become less perfect in time. So that doesn't refute his proof of God's existence. It would certainly lead you not to want to set sail in search of the perfect tropical island that you dreamed about last night. Definitely that might be a mistake. Or not, but probably a mistake. Okay? What else do we have? God exists only if you take into consideration those assumptions. Well, Matthias, this is a logical argument, and every time we make any kind of logical argument, we're always assuming something. Euclid, go back to Euclid's Elements, the basic paradigm for geometry and hypothetical deduction in science. It's a book that's 2,500 years old, and it's the paradigm. He makes certain assumptions at the beginning and uses those assumptions to build a whole corpus of reliable knowledge about geometry in the plane and to prove all kinds of theorems. So whenever we argue something, we're making assumptions either explicitly or implicitly. You can't have an argument without assumptions. So the argument is that you're assuming God to be the greatest conceivable being. And if you're going to try and change that assumption, of course you're going to change the argument. But Anselm would say to you, but if you assume that God isn't the greatest conceivable being, then you're not talking about God. So that's a non-starter. In order to absorb Anselm's argument, we have to absorb his assumptions, at least as far as they go, unless you come up with these rather brilliant kinds of objections, such as Plato might have made, and we'll see on Thursday what the others are. If you want to look ahead, and I encourage you to, because there are refutations. I mean, we've been debating this for 1,000 years, and some of the refutations are very clever. So, there's a link in your Google Drive folder in Supplementary Materials Part 3, right, where you'll find this stuff. There's a link to a page which has a really good summary of all the main philosophical objections to this argument. And you want to have a look at that and see if any of them align with what you might see as problematic. How would Anselm view the idea that humans have free choice? Well, that's a very good question also now, man. It seems to me he doesn't talk about free will, but he's obviously assuming that we have some capacity to think freely. He's not really addressing the idea of free will, but implicitly, it seems to me, he is admitting that we have the ability to conceive of great things, yes? Whether we do so freely or not is not directly the point, but we certainly have no limitations to what we can conceive. I think he will concede that. As to whether we are free in the ability we've been given, whether we conceive great things freely or not freely is really a separate question. And the free will argument is not necessary in order for us to believe in this proof. What is necessary is for us to understand the sort of remorseless deductions of logic. We do need to understand that if we have a disjunction in the first statement, that one or the other of those must be true. Okay? If the second disjunct is true, then God truly exists. We have to be, in a way, constrained by the laws of thought. So freedom of will, in terms of like, what am I going to have for breakfast this morning? That would say, those who believe in free will would say, you're free to choose, maybe, what you have for breakfast this morning, but you're not free to choose what 1 + 1 equals, because that's going to be told to us by the laws of thought. And laws of thought are not in contradiction with free will, but they are going to be laws that, as far as rigorous thinking goes, as logical thinking goes, validity of arguments goes, they're going to be as compelling to our thought process as the laws of nature are to physical, chemical, and biological processes. Okay, so the laws of logic have a certain sway in the world of mind, and that's what we recognize. Whether we do so freely or because we are we compelled to recognize them, or do we freely accede to them, is a different debate. Totally different debate. And we're not going to look at free will in this course. We will a little bit in the next paradox next week. The prisoner's dilemma, definitely. Okay, so hang on to that. All right, we're out of time. Are there any other questions before we wrap it up this morning? Alexandra asks, what if in some isolated place a person does not have any imagination of a greatest conceivable being? Interesting. So if you had no imagination of a greatest conceivable being, that would tie into, maybe that's like a child before a child hears about God, right? Maybe a child could live to be a few years old and never hear about God, and then someone would mention God, and then the child would say, well, what's God? Or who's God, right? The first time you hear about God, you might ask that question. And that would mean, I think Anselm would acknowledge, that would mean that God did not exist in your imagination yet, right? If you hadn't heard of it. But it doesn't mean that God does not exist in reality. So again, we're back to that answer I gave to Nama, I think it was, on Plato's question. So, there could be things that exist in reality, but not in our imaginations. And if you think about a child who hasn't yet heard of history or geography or planetary astronomy or God or religions, well, those things exist in some sense, but not in the imagination of that child, but they still exist in some sense in reality. So that would be a third possibility. But Anselm is not concerned with that. He's trying to prove to adults who've already heard about God, whether they believe or not, he's trying to prove to adults for whom God exists already in the imagination alone, or in the imagination and reality, that God must truly exist. Okay? But I certainly concede that there could be things out there, for example, intelligent life on a different planet. Like that might exist in reality, but yet not yet in our imaginations, because we don't know about it, right? But that's outside the structure of this proof, okay? That's a third possibility which doesn't really embroil itself in Anselm's argument. Okay? So listen, thank you very much for your, I think, quite interesting comments, at least at first blush, seeing this. For those of you who haven't yet seen the argument itself, the light hasn't come on. Keep reading it. And Voltaire said if God didn't exist, we would invent him. Voltaire was an atheist, but Voltaire said, if God didn't exist, then humans would have invented God. Okay, so that's a different point, Randy. If no one were taught or heard of God, they wouldn't think about God. I doubt it very much. My life experience seems to suggest just the opposite, that it would be really neat to do the experiment, wouldn't it, Randy, to imagine a planet where, like, identical to ours, except there are no religions, and then see how long it takes for someone to invent a religion. I don't think it would take very long. Okay, you know that? L. Ron Hubbard did this. You've heard of Scientology? Maybe some of you are Scientologists. But the backstory is that L. Ron Hubbard was, before he became the inventor of Scientology, which is some people say a cult, some people say a religion. I know Scientologists. I mean, it's a big thing. And whatever it was, it didn't exist in reality until it came from his imagination. And what he did was he cooked it up. And the backstory is that he was playing poker with some friends one night. And, he was only a kind of a mediocre pulp fiction writer. And they were discussing this very question, Randy, about religion. And anyway, L. Ron Hubbard said, I'll bet I could invent a world religion. That's apparently the origins of it. He said, I could invent this. I could invent a new religion. They were talking about the same question. Are religions invented? Or did God give them to us? And L. Ron Hubbard bet with his poker-playing friends he could invent a religion. Well, he won that bet. I don't know how much he gambled, but he certainly won the bet. Okay? So, I mean, that's a case study, if you like. And I think that if there were no religions for some reason, that we would invent them. Without a doubt, we would invent them. And I think they're all invented, actually, if you want to look at it from that standpoint. But that doesn't prove that God doesn't exist. It only demonstrates to those who believe that God created us with the capacity to realize that God exists and to invent religions in order to in a way, get in touch with God, right? Think about it. But please understand Anselm's proof, okay? That's your challenge. And I will look forward to seeing you on Thursday, my group M, and we'll look at the objections that are historically the most interesting from some philosophers we already know. And then you will decide whether you still buy this argument or whether one or more of the really good rebuttals on record are convincing enough to you to be able to spot what they think the flaw is in different ways. Okay? Listen, have a great day, everybody. And I look forward to seeing you. Next week is the prisoner's dilemma. This is a huge and very interesting topic. So hang in there. We're getting toward the end of the course, but we still have some really fascinating ground to cover, and I look forward to covering it with you. Take care, everyone. Be well. See you soon.